In 15.3, we're looking at acid-base reactions. So first, we're going to look at what's called a conjugate base. And this is the species or product that's left after a Bronsted-Lowry acid has given up its proton. So here we can see HF is our acid. When the proton or the hydrogen ion is removed, what's left is the F negative. So that would be the conjugate base to the HF or hydrofluoric acid. A conjugate acid is what's formed when a base gains a proton. So in this case, water is our acid, our base, and then it gains a proton over here and becomes H3O positive. So if water is our base, then H3O positive is our conjugate acid. You will always have two pairs when we're looking at these reactions. So in your reactants, you're going to have an acid and a base, and in your products, you're going to have an acid and a base. And so when you're pairing those up, we can see that F fluorine is in both HF and then F negative. So the one with the extra hydrogen in this pair is going to be your acid. So then our other two, so water, and this is called hydronium, whichever one of those has the additional hydrogen will be the acid. So hydronium is our acid, water then would be our base. The stronger the acid in the pair, the weaker the base will be, and the stronger the base, the weaker the acid. Typically, when you have these reactions, they're going to favor producing weak acids and weak bases. Amphoteric means that you have a substance that can be an acid or a base. And so if we look at this reaction, we've got water in this first situation is acting as our base, and in the second situation, water is acting as our acid, because here we have, in the top one, we have H2O is paired with H3O positive. So the one that has the least amount of hydrogens out of these two is just water. So that would be our base. Down here, H2O would be paired up with OH negative. And of those two, water would have more hydrogen, so that would be the acid. So we can see that water can be an acid or a base. So this is what's called an amphoteric substance. OH can also be amphoteric. Sometimes it can be a base, sometimes it can be an acid, or it can be either amphoteric. So this is a hydroxyl group, and often oxyacids are going to have these OH bonds located on them. When you have a neutralization reaction, an acid and a base are going to react together to neutralize each other. And when that happens, your hydronium and your hydroxide ions are typically going to form water. They're also going to produce salts. So salts are going to be composed of the cation from your base and the anion from your acid. When we're looking at acid rain, typically we have heard about acid rain and we think, oh, it's harmful to the environment. But these are going to be made from what are called NOx and SOx compounds. And these are going to come from air pollutants most of the time that are going to have nitrogen combined with some substance and sulfurs combined with other substances that are then going to produce acidic solutions in the air with the rain. And we know they can cause damage to buildings, statues, they can cause harm to the environment. If water, ponds, lakes, streams change pH levels very much at all, it can harm the life in and around those bodies of water.